All right, good morning, guys. So we're coming to the end of chapter 9. We're going to break the last lesson up into 2 days. So today we're going to start lesson 9.7, and we're going to talk about the law of sines, and then tomorrow we'll come back and we'll talk about the law of cosines, okay? So the law of sines and cosines, it's going to help us solve any triangle. So far we've been doing right triangle trigonometry, SOHCAHTOA. We use SOHCAHTOA when we have a right triangle. We're always going to have like sine of the acute angle, cosine of the acute angle, and tan of the acute angle. But the law of sines and cosines allows us to work with triangles that aren't right triangles. Okay, so we will need our calculator. Our calculator will have to be in degree mode. Forgot my calculator in the other room, so I'm going to go grab that. Hold on. Okay. And I already wrote up a bunch of stuff just to kind of give us a head start. So we'll work through this, and then I have a few more examples to go through. Okay. So finding trig ratios of obtuse angles. So like I was saying, with right triangle trigonometry, we're always finding tan of an acute angle, sine of an acute angle, cosine of an acute angle. But we're just going to use our calculators and plug in to see what values we get when it's an obtuse angle. Okay, so everyone with your calculators, again, remember it needs to be in degree mode. If it's not, hit that mode button, which is to the right of the blue second button. Go down where it says radian, move over to degree, push enter, okay, and then just second mode again to quit back to the main screen. All right, so we're going to plug in tan of 150. To see what kind of value we get, and we'll round these to 4 decimal places. All right, so here I have approximately negative 0.5773, or I guess, sorry, that would round to 4. Okay, the next one, sine of 120. Okay, and we get approximately 0.8660. And then finally, cosine of 95. All right, and we're going to get approximately negative 0.0872. Okay, we round to the 4th decimal place. All right, so moving on, we're going to now look at the area of a triangle. I set up a triangle here. We talked about this in an earlier lesson. We name the angles A, B, and C. Across from angle A is side A. Across from angle B is side B. And across from angle C is side C. Okay, so that's important to know how to label our triangle. So we have 3 area formulas that we're going to be using. The area equals 1/2 BC. BC stands for side B, side C. And then sine of angle A. Area equals 1/2 AC, sine of angle B. And then area equals 1/2 AB, sine of angle C. Okay, now notice A and B are the sides, and then, or excuse me, saying the wrong letters. B and C are the sides, and then we use angle A. A and C in the side are the sides, angle B. Okay, but it's always going to be A, B, C, all letters are used. So I'm just kind of pointing out ways to memorize the formulas. All right, A, B, and C, A, B, and C. So you can kind of help yourself memorize the formulas that way. All right, so these formulas. All right, it says over here, it's 1/2 the product of the length of 2 sides times the sine of their included angle. So if you notice sides B and C, here's side B and here's side C, included angle A, right? The next formula, sides A and C, and included angle B. And then sides A and B and included angle C. Okay, so that's another way to help you remember the formulas. So we're going to be using those formulas. Let me erase some of the boards so that we can get a problem up here. Try to leave the formulas up for us to refer to for some of the problems. Okay, so the first problem that we're going to work on example 2. Finding the area of a triangle. And here's the triangle here. Angle A, angle B, angle C. So this is side A, side B, and side C. And the given information, this is going to be 19 units long, 17 units long, and 135 degrees. All right. So we, when we first learned how to find the area of a triangle, we'd always use 1/2 base times height. Base and height always have to be perpendicular to each other. We don't have perpendicular sides here. This is not a right triangle. And although in some situations we might want to draw a perpendicular line to the base, and maybe we have enough information to find those missing pieces of information and use our normal formula, 1/2 base times height for the area of a triangle, sometimes it's not possible. So then we use the laws of sines, okay? So first thing I'm going to do is I'm going to identify the fact that I know that side C is 19 units long, B is 17 units long, and the included angle is 135, okay? So, and the included angle is angle A. So to find the area of this triangle, I'm going to set it up. Area is equal to 1/2 BC sine A, and then fill in the values. So B is 17, so 1/2 times 17 times side C, which is 19, times sine of angle A, which is 135. Okay. From there, it's a calculator-based problem. So I'm going to plug all that into my calculator, just as I see it on my screen. So it's 1/2 times 17 times 19 times sine of 135. And you get an area of approximately 114.2. We'll just round to one decimal place. All right, so the area is approximately 114.2. And it will be units squared, but I don't have units here. Okay. All right, let's do another problem. I'm going to erase everything this time. All right, so for the next example, okay, so another